an INSAR image, which is a difference between two radar reflections, and they're out of phase with each other. And because they're out of phase, we can actually calculate the difference between the two phases and equate that to a change in the position of the land surface, how much it's moved. And so this was 25 millimeters, which is about an inch of land subsidence, just over from February 2008 to April. So just over a few months, we're seeing some pretty intense deformation occurring just right in that area here. These satellite graphs, but it's very difficult to do that type of analysis in ag areas because the farmers are out there moving the land around. So it's hard to get a stable reflection when they're moving the land around. So we select stable points and use those as a point of analysis. We also have, luckily in the valley, two of continuous GPS, which are geopositioned satellite recording stations that are part of the Plate Boundary Observatory network, which they're actually looking at the plates moving on the Earth's crust. And we have them in the surrounding mountains, and we discussed that in the first report. We show all that time series data. But we also have two in the valley, one at the high school and one up at the ranger station at Benchcote. So this is the high school, so this is the deformation from that. And then this is our simulated deformation. These are some of the points. The blue is measured and the red is simulated. And it's still a few tenths of a foot. And like I said, the old timers used to say, don't even call me until you get a couple tenths of a foot of subsidence. Well, we've got a couple tenths of a foot of subsidence. And possibly more. We simulated up to about 1.6 feet of subsidence in the valley, in the main zone, parts of the main zone. This is the Benchcote, so you can see that it's just oscillating elastically. So this is starting to become permanent deformation, but you can see these oscillations on it, and that's actually the deformation from cyclic pumpage, seasonal pumpage. So we have land subsidence starting to occur in the valley based on current water use. Next slide, please. And then finally, the other thing that I wanted to show you is that we did do, as Tom had suggested, at least a couple of bounding cursory simulations to kind of show what might happen under certain conditions. And so these are some ones that kind of bound the water use and water availability and issues for Cuyama Valley. One is business as usual. So we go forward into the future. We use historical hydrology from 1950 through 2010. We use that stream flow and rainfall and ET, potential ET, into the future. But we go through so we're going through the years backwards with the months forwards, and on top of that, we hold the land use to 2010 land use. And we say, well, what would happen if we just kept doing what we're doing? And so what we see is, again, changes in projected groundwater storage. So we can see that we lose about another 2.5 million acre-feet overall. And then again, most of it's coming out of the main zone. Some of it is coming out of Benchcote, and there's just a little bit more of the storage accretion going on in Benchcote overall. The second scenario that we looked at is reduced supply. And that's really where we would set pumpage, and this is a simplification, but basically pumpage is equal to long-term annual average recharge. And so what if we're trying to, and there's a bit of a myth about water balance. There's a great paper by John Breedhoff about this, but this is still a commonly used estimate would be to just say, well, what if limited supply, in other words, what's pumped out of wells to what's replenished. Clearly it isn't replenished evenly everywhere. There's a lot more recharge going on in Benchcote than there is in the main zone, for example. But if you take this scenario, what we see is that we arrest storage depletion overall, which is the blue dashed line. The line that is superimposed on it is the main zone, so we've actually arrested storage depletion overall in the main zone if we bring these two into equal. And by equal, I actually went to each agricultural water accounting unit that was using water and prorated it based on how much they were using typically in 2010 to on a month-by-month basis. So I didn't just smear it out. We actually tried to mimic what they were trying to do historically from the historical part. We We see there's still some storage depletion going on in in Sierra Madre foothills, and a little bit of accretion in Ventura. These are much smaller numbers than these. If you can see that this is 2 million, or excuse me, 3 million. This is a few hundred. So the third scenario that we did is reduced demand. And so the way you reduce demand is that you stop needing the water. So one way to stop needing the water is to get rid of or stop the agriculture in the main zone. That's not sustainable for agriculture, but it is a bounding example. I'm not advocating any of this. These are just bounding values or scenarios that allow you to do that. So if we stop agriculture, and the way we do that in the computer model is that we replace the agriculture with native vegetation. So there's still ET going on. And actually, there is a small amount of recharge, artificial recharge, that does occur because irrigation is not completely efficient. Right? So you lose some of that, and that goes on. And what happens here is that you see some rebound overall of the entire valley. We still see some storage depletion occurring in the Sierra Madre foothills, but accretion now occurring in the main zone and in Ventura. So this is part of the myth of the water budget, is that what you can start to see is what is available water resources and what is the sustainability of these resources. And in particular, you get to the point where even after 60 years, we've only recovered, if we do something extreme like this, which is unlikely, we're only recovering about a quarter to a third of what was taken. So not that we're trying to bring the basin back to what it was naturally, but it takes a long time to evoke any kind of recovery that's significant. Next slide, please. Okay, so let's look at that in the context of water levels. These are from our multiple well monitoring sites. One is Cushman Road, the other one's at the corner of Bell and Foothill Roads, up in the Sierra Madre foothills area, right across from a large ag producing well right across the street, Cattywampus. And we can see that the business as usual, that we have considerable decline going on in all the layers. So, and we also see that at Bell and Foothill Road for the base case. When we look at reduced supply, we stop the declines in the main zone, but we still have some declines going on in the Sierra Madre foothills. And then when you reduce demand, we get actual recovery here, and you start to reduce the declines in the Sierra Madre foothills in that region. So that's in a water level context to get a better feeling of what's going on. Next slide, please. And then, in the context of land subsidence, projected land subsidence, what we see is that if we continue with business as usual, there's a potential of at least another, at least at the high school, of another about 0.6 feet of subsidence. What happens under the other two scenarios is that we start to get elastic recovery, so there's just a little bit of a rebound occurring here, a small amount. That time period.
Did you say 26 feet? I'm sorry, I didn't.
0.6.
Oh, 0.6, thanks.
Right. This is in feet. That's 1 foot. That's about 0.6. No, that would be central, not.
Yes.
For Mexico City. So, next slide, please. So, in the context of just looking at what the additional decline would be over that projected period for the business as usual, what we see is that we have about another 300 feet of water level decline that occurred in the main zone, in this region here, but we don't really see much decline, actually even some additional recovery in the Ventura uplands here. We see a little bit of decline in these regions here, but much more modest. So this is really still potentially an issue of another 300 feet, whether really that part of the basin can endure another 300 feet, whether we want to go deeper with their wells and so on in that area, continue to drive land subsidence and other issues. Next slide, please. So that's pretty much it.
We have the lights back now. So I told Randy 35 minutes, and I think it's almost to the button. He finished that in 35 minutes. I want to thank Randy for that. Very complicated stuff. So what we'll do now is we'll start with questions. And we have plenty of time here. And if we could keep, so everybody can hear, keep the background noise. If you have to talk about something and you want to go out to the end, that's fine. So we'll just start right here. And if you could say your name and
Thomas, down by Rock Valley Road. Yeah, sure. I saw a lot of thousands and 2,000s, etc. on the side. I believe most of us have our wells around 200 feet, 100 feet, 200 feet. We may have water anywhere from 30 or 60, some 300, maybe more of the ag pumps. Closer to Cuyama being maybe much different. I'm not familiar with how big they are. So how does the 1,000, 2,000 stuff that you were saying, where the water is and our wells are down to relate to us?
The Cuyama study, which did almost all of those age dates, were predominantly looking at water supply, which included municipal water supply or agricultural wells. They did not, in most places, look at domestic wells. They're making a second pass right now through California looking at domestic wells. So those age dates did not pertain to shallow domestic wells.
Could you take a hand reading of quickly ag wells that are more than 1,000 feet or less than 1,000 feet so we can relate?
Yeah, I'm talking age. Those were ages in thousands of.
On the left,
Yes.
but the years were on the bottom.
do you want to go back to that?
Yeah,
slide?
I don't know what slide you were. I thought you were talking about the
There were
age
several.
dates. What are you talking about?
And many of them got.
Well, he talked about age in thousands. He talked
Yeah.
about storage depletion in thousands of acres.